Hello? Hey, cool. Okay, thanks for coming. Full room, amazing to see. So let me start with a story before I tell you what we're doing today. So this talk I wanted to give for a very long time. I had like of my want-to-do presentation list, and I submitted it to a couple of conferences. We're talking like 2018, 19. No one wanted this talk. Never got accepted. And then I was speaking at DroidCon Amman earlier this year, and that's why it says DroidCon Amman up there. And then the organizer said, Danny, do you have a second talk available that you can do? I said, no, but I have one I always wanted to do, that I just recently, we've actually found in my archives that I never written. I said, yeah, let's do it. So I prepared the first version of what I was going to see today, but then our conferences happened. They had to change the agenda, and my talk was dropped. So it never happened at DroidCon Amman. Then finally, 2 days ago, I was in Prague on an event. I did the first version of this. I used this laptop here, like I tried to do today. 5 minutes into the presentation, the laptop froze, had to reboot, and this happened every 30 seconds to 5 minutes. So it was an amazing live coding experience. So I want to thank you, Margareta, that just spontaneously gave me this laptop today. So this is not my laptop, so if I struggle, this is because, I don't know, this is really a keyboard here, and definitely not the one I'm using usually, but we have a setup that's working, and hopefully will always be better than me rebooting my computer every 5 minutes. Cool. So I want to talk about Kotlin Reflection. And this is all live coding, so there won't be any slides. I will post some links in the end for more information. And maybe I find a way to share the rest in some slides I can put together. But the idea is, let's just code together, and or you watch me coding, and then we'll see how this goes. So I have to give you a warning. And this is a warning from the official Java documentation. As reflection, this is a relatively advanced feature. It should only be used by developers who have a strong grasp of the fundamentals of the language, because it can enable applications to perform operations which would otherwise be impossible. So I hope you are prepared. This is the warning from Oracle. And let's dive in. So I asked, so what is reflection? Let's ask Wikipedia. In computer science, reflective programming, or reflection, is the ability of a process to examine, introspect, or modify its own structure and behavior. Sounds cool, definitely interesting. I always like reflection. This is what the Kotlin doc says. Reflection is a set of language and library features that allows you to introspect the structure of your program at runtime. So functions and properties are first-class citizens in Kotlin, and so must be the ability to introspect them. For example, learning the name or type of a property or function at runtime. And this last one is interesting, because this is essential for using functional interactive programming. So even if you think you don't use reflection, and remember like back in the Java days, reflection was like this magic thing where we had really ugly code. It was super cool, but also scary. Nowadays, actually using reflection all the time without even noticing. And I want to show you why. That means let's write some code. So there's nothing prepared here. It's a weird, okay, I should have brought a chair. Cool, I have somewhere in this project a method called isOrt. It takes an int and returns a boolean. Cool, let's assign this to some variable. So let's call it, I don't know, I'm not very creative, isOrt. So what's the type of this? So we can declare this as a lambda that takes an int and returns a boolean, right? It's probably how we can write it. Cool, works. But this can also be, let's take the amazing name isOrt2. This is also a function, and this is a Kotlin.function that returns a boolean. This is also another amazing name here, a k function, which is another reflective type k function. This is also a thing called a k callable. Cool. So one of the same thing we can assign to many different types, and this is where I want to start to show some what's behind of those. Okay, let's try to make a screenshot before I delete the code. No traces for this detective over here. By the way, great talk. Okay, k-class is the one, if you have never touched with Kotlin Reflection, you've seen the k-class, because all you have to do is, let's, for example, let's assume I have an Android makers class somewhere. Cool. And I do .class. This is a k-type. We've all handled this. So what can you do with a k-type? You can actually ask it a couple of things. that shows us why we need this and not the class in Java. You can ask this, hey, are you open? Are you actually fun? So functional interfaces. You can actually ask it, so is this a sealed class? Is this a companion class that you're looking at? So there's some interesting things. There's the usual things like Java has. You can ask for its members. Members is an interesting one, a little bit different to Java, because members is all function and properties in this class. So they're mixing both in the same bucket, which works a bit when you think about how you use Kotlin from Java. Like properties are also kind of like functions, the way you access them. And if you run it, there's declared properties and there's declared members and members. So one is the one that you have in this class, and one is the one that you inherited. So if you want to have the differences, you can ask for the properties. For example, there's the static properties. I mean, all of these things are available. So looking at the K class can be very interesting, and you find like interesting things. And all of these are basically on top of what the Java version gives you. That would be this thing. But we're not looking at this right now. There's one big differentiation, or one big understanding we have to do. So this is a class. There's also a thing called a type. So where's the difference between a class and a type? So let's look at it. Let me look at an example. So a type can be actually a class with type arguments. So the type of string is the class string. Sounds simple, right? A type parameter of some declaration. So list T. T is a generic type. So this is where type comes in. There's also an interesting one called type erasure that we look at. So you can also type can be removed at one time in the Java world and when going from Kotlin to Java. And types can be nullable, which a class is just a class, but a nullable string is actually the nullable string type. So you can think of this. So how do you get a type? So it's a bit easier nowadays. So when I first looked into Reflection in Kotlin, this wasn't there, but you can do something like, give me the type of an int. This returns you a so-called K-type. Cool. Or else can you get a type? Let's assume we just looked at our Android makers class. We want it to come on. I don't see a thing here. I probably see less than you do. Cool. So we have our class. We want to instantiate it, right? So we need the constructors. Cool. I could now create a constructor if you want. Let's get the first one, and we can call it, but we're not doing this now because we need to know which parameters does this constructor need. So we ask for is parameters. Cool. Let's grab the first parameter, so don't write this in production. And then we can ask for its type. So this was something we actually would use the thing called a K-type. So give me all the parameters, and I'll show you an example where we actually do this and try to figure out a type. And then, because I wanted to initialize this thing then with something random, I had a use case for that. So this is one way, and then there's another a bit easier way. So whenever you have a class, a K class, you can actually create a type. And this has some parameters. For example, is this nullable? You can add some annotation. This hasn't been there in the first place on the class. So you can take a class and create a type out of it. So far I hadn't had a use case of this, but this is how you transfer the two worlds. And from every type, by the way, there's a thing called a classifier, which is mostly a K class again. So you can go back and forth between the two. So right now we're not going into this and starting a bit more easier. Let's talk about functions. That's something we all know. We need a function. Where can we find a function? Let's look at our Android makers class. And there is a method, let's pick one. We have here has started. So has makers already started. I think it was opened this morning. So we grab this Boolean function. And let's assign it to, I'm great with naming, fun1. And let's do the same thing that I did earlier. So this is a function that returns a Boolean. Wait, there's something missing here. That returns a Boolean. Not one up, yeah. Up. Actually, should be a class on Android makers, isn't it? Oh. Wait, I know here. Here's my mistake. We put Android makers, that's class, and this is a class on the. Oh. Cool. So I could declare that this is just a lambda. I need an instance of Android makers to return a Boolean. So let's show you the other thing again, or the other two things I showed you earlier. So let's duplicate this. So this can be this function, and it's not Java reflect function. This is Kotlin reflection function. This returns a Boolean, and we do the same with the other one. This is the K function, and then we look into where's the difference of these things. Sorry, I'm a bit slow with this, a bit older keyword, but I'm very happy that I can code it all. Cool, let's give these three names. So where's the difference? Function is actually a bit the binding, the glue between the two. So when you look at the definition of function, it is empty. It's basically just a marker interface. So it represents the value of a functional type, such as a lambda, or anonymous function, or actually a function reference, which is the properly K function. So kind of the first one is a function, and the first and the last one, K function, which is the property reflected one, implements function. So this is a bit how they try to grab this word. It's the same thing behind it, but we can describe them differently. So if I can assign the same thing to them, can I do something like fun equals fun2, fun3? So can I assign the K function lambda? No, doesn't work, it's not that easy. But then, I don't know, by definition, how we learn the computer science, right? It should work the other way around, right? So fun1, so you can see my work. This also doesn't work. That's super weird, right? Shouldn't one of them work? And there's a super fun one, no pun intended, it's called reflect. So there's a method that you can call on a lambda that tries to create this K function out of it. Because K function in the end is just a construct that describes what this thing is, how to call it, which is easy with a lambda, but also has more things around it. We'll look into the implementation later, so don't worry for now. But it's a very interesting one. It is marked experimental, and it has a lot of issues when you try to run it. But the implementation is super interesting. So just what can we do with K function? So let's take the third one. Nope. We can call it, right? So easy. I would need the arguments the way we showed. I can actually call it because it's a, let's actually not run this here. It is a K callable. We saw this maybe. Maybe you saw this, let's go back. So every K function is a function and a callable. So it's actually very easy. Two things are callable in general, functions and properties. And we'll look at both of them in a second. So when we do something like this, fun3 dot call, we just use the callable interface. And this is our arc. You can pass all the arguments. This is why reflection is like dangerous, because the compiler will not help you. At one time you'll figure out, wait, there was an argument. And also like optional arguments you have to pass, because the way we're going back. So unless you're doing the JVM optimization, it's like you're going back to Java world. I don't think there's much that I want to show you on K callable, except for that it's the same for properties. So let's go to K properties. So Android makers has some properties, for example, date. I mean, a conference need to have a date, right? So let's assign this to something. Well, I don't know, the date. It's the one date we need to know of the year. Cool. The type of is actually either a K callable or a K property. And just because K property implements and of type date, Java date. So easy. How do you get it? You .call and then you get it. There's a nice one that K properties also hit. You can pass on the getter, which is super cool. So there's K property getter. Never use it, but interesting class to look at. You can pass the getter to a property, which sounds like the same thing. But it gives you less thing. And in general, all the good things, you can figure out, is this a final property? Is this late in it? Like all the things introspect at runtime, how is this used? And now you might ask yourself, wait. This K property thing, I have seen this before, maybe in my code. There's a thing called property delegates. And this is one of the things where you might have seen reflection. And even if you have never written a delegate, you definitely use one every day. Probably one of the first things you used in Kotlin is by lazy. Lazy is a delegate. And you can write your own. There's a few others in the system that not very used. I have a full talk somewhere that I gave, I think in Munich once. You can find it. By the way, let me just open this for time. But you can be very powerful of things with it. So let me show you what you can do with delegates. So what is a delegate? Let's assume we want to create a conference. So the next cool, awesome conference, awesome conf. Nice. What does a conference need? It needs speakers. And wouldn't it be cool when we just get all the speakers from a cool conference like Android Makers? Nice. So whatever Android Makers adds to the speakers, we want to invite them to our awesome conference. So how does this work? We have to implement this. And this by, like by lazy, is a property delegate. So let's create one. And there are two ways you can create one. We can implement something in Android Makers, but they don't want that we change their class, right? But that's why extension function comes in. We can implement a delegate for Android Makers outside of Android Makers. Cool. So the two parameters, one of them is this K property thing. So for example, implementation could, let's assume this returns probably list of speakers. Speaker. There we go. And then we just return the speakers. I mean, it's not about the implementation here, but the things you can do. So whenever someone says by Android Makers, you get the info of the property itself, and then you can ask it, so who are you? Are you late in it? Did they declare you final? It was like very interesting things. So before you give even the answers of the speakers, you can figure out how is this thing used. That's very interesting. And then there's this second dude here of type any. What's this? Who's this guy? Let me show you something. I hope it didn't move too much. We were here. No, we were here. Let's assume we are not creating conference and we just want to have the speakers. And we're just doing the same thing again. Create the extension function makers. Ooh, now the any became nothing. Because this first parameter is the surrounding class this delegate is used. So as we're not using, I'm just using it main here, they will never be passed anything. So if you use a delegate on the global level, you will not get any context. So we can figure out how the property is used, where it's used. Let's do some cool shit with this. Just to finish the delegation part, we can also implement it in Makers itself. Looks the same way. It's just a operator that you have to implement, get value. There's a marker interface I showed up here, read-only property. This is like the function, it's just a marker interface. If you write a delegate, it's better to show this because then people know what this thing is. But it has no value. This is why you can write extension function. You don't need to implement this. It's just for you to know. Cool. So let's write something cool with this introspection timeframe. So let's assume we have some class. And I'm very good with names. I call it something. And something has a value. My value. And it's of type, let's say, int. And the value is gotten by some property delegate that I already prepared for you. Property delegate. Delegate, wait. Capitalized property delegate, there we go. And it takes some initial value. Let's say it's 0. So some value by some delegates, we initialize with 0. And then we write the same thing again. Command D. Up. And let's assume this is a unit test. This is a unit test for something, and we exactly the same thing. And let's just, I mean, it's not a unit test, but I'll show you later how we can properly. This is just an example. So let's initialize something. So create something and ask for my value and print this. And we do the same for the second one for something test. Oh my God, let's run some tests. We haven't run anything here. So let's make this a bit larger here. My value was not declared in a test. That's the first one. Its value is 0. The second, my value was declared in a test. Its value is 247, blah, blah, blah. So here, it's just a small idea of what you can do with this delegate. So look at this. So this is the way you usually would write a delegate. You have like an operator provide delegate that just creates a read-write property. And isn't this weird? Okay, it takes this any parameter I showed you, and let's check if this is a test. And the most stupid implementation could look like this. Does its name end with test? not very clever, right? So we thought about, asked a colleague here, do you have a better idea how to do this? And then he has this, let's use some Java reflection, because Kotlin didn't help us here. So let's grab the stack trace of the current call and try to see if there's something with org JUnit in there. So also not the best implementation, but this is how you could introspect and completely change the behavior depending on where your property is used. And maybe after the call, you can have some crazy ideas and go back to work, and then hopefully not, your colleagues will not hate you because things behave very differently on their computer and yours. Cool. Yeah, let's move on. Small thing to mention, are we in time? Pretty good. Coroutines. Just in case you run into this, coroutines, reflection was there, then coroutines come later, right? So how do you do the whole thing? Android makers, my Android makers instance, has a method called start event. Cool. Let's just call it the old school way of auto reflection, right? Is that, oh, the suspend function, you can't call it like this. So let's do the evil one that, of course, we never write. Cool, working now. But what if we do the whole thing with reflection, right? So let's forget the one while clicking. And let's get the started event. Whoop. Android makers. Start event. Cool. So let's assign this to something. Well, I don't know. I'm very creative again. My callable. Of course, it's a callable, right? And then I would try to call it. So my callable.call. Like I did before, I need an Android makers instance, so I just pass one and run it, right? This is supposed to be a coroutine. Let's see what happens. The compiler does not complain. Ooh, at runtime it fails. Hey, there should be 2 arguments here, not 1. You can probably guess which argument is missing, because we're going all the way back to bytecode. There's a thing called continuation that you need to run if there's a coroutine. This is why the callable has something like, hey, am I a suspend method? So you first check this, and if it says true, then please call suspend. And then, hey, you need to run blocking call around it, and then all of a sudden we work again. This is what makes reflection a bit tricky. So if you imagine you checking all your code and all the methods, is this a suspend method, then do this, otherwise do this. A bit ugly, but this is how coroutines are completely supported here with reflection. Cool, let's go on. So let's talk about Java, because that's what you all want to understand. So let's take a bit deeper after we saw some examples what you can do. So Android makers.class, right, is the K class. And then there's the little brother, or the big brother, called Java, which is the Java reflection class. How do I go back? Oh, I can ask the Kotlin version, which is the K class again. Oh, by the way, I can go back to Java, and then you can do this endlessly. It will work. So why would you use one or the other? Good question. Let's look at some things that K class gives us that helps pitching with these 2 goals. So let's think about the class Java. So you can ask a K class for its Java object type or Java primitive type. Because remember, the things from Kotlin gets translated to something different in bytecode. And there's all the boxing happening. So let's look at this amazing implementation I will show you of the Java primitive type. Sorry. Some talk must be really bad. So the Java primitive type is a very complex function, as you can see. Someone just hard-coded all the Java classes and said, okay, Java lang Boolean is a Boolean in Kotlin, and this way. You can't add anything there, because this is what the compiler gave you, right? Very simple class. You can think, maybe, can you optimize this? We shouldn't. So this is like, you can do these things. Remember when I told you about the types? When we had a type of Android makers. Types also have JVM erasure, which is also a very interesting one. Look at the documentation. The K class instance representing the runtime class, which the whole thing gets erased to. Remember I mentioned earlier that there is a thing called type erasure in general that you have to be aware of. So in Java we know this, a list string and a list, I don't know, integer or long. in runtime, because the way it was implemented in Java 4, right, it's the same thing. It's list of object. So there's the first hypervisor happening. And then when we go to Kotlin world, as I just showed you, also a Kotlin string gets translated to Java lang string. So there is a type change happen there as well. So when you had a loop of reflection, for example, because you're writing some serialization library or something, you have to keep this in mind. And this is when you have to cross these roles all the time. I will show you some examples where, for example, you have to some of these lookups. And as the other example, sometimes you have to use the Java reflection, because we'll come to limitations. Kotlin reflection doesn't give you everything Java gives you for a reason. Cool, how does this whole thing work? This is why we're all here, right? But how? Especially when all the types get erased. And then you can get this Kotlin class, just .java.kotlin, and make it there again, the K class. Where do the information comes from? Let's look at some bytecode. So, sorry, Android makers, let's just jump to the class. First like this, whoop. And then we do show bytecode. I never run this on this computer. Otherwise, I have this other computer. We can try it probably for 5 minutes. What does this do? There's something went wrong. I would so to show bytecode. Okay, cool. But whoop. Last one maybe auto. Yeah, that's fine. Actually, I want to have. There's no decompiled version because probably we didn't install this here. Wait. How do I get rid of this? Open find tool window. So this is the bytecode viewer. But what I wanted is to show you the decompiled version of it. So first, show toolbar, open spell up. Yeah, exactly. But do you know how do we get it in IntelliJ? It's a fresh IntelliJ installation. The good thing is for this one I'm prepared. So what you would say, what I want to do is I would show a bytecode and then use the decompile to Java version, which gives you a rough idea so that we don't have to look at ugly bytecode. It will show you, and you see this in every Kotlin class that you actually look at, there is this weird, wait, let's just return to the file we've just been. You will find something like this. There's a metadata annotation sitting on all of these classes. And you will find them everywhere, and you might ignore them. We're just browsing too. There's some nonsense rubbish here, right? So this is what you would have seen. I'm glad I made a copy. And there's some 1.190, 1.2. I can see some methods here. Dwight Prague. There's no Dwight Prague. Someone didn't do a proper renaming here when he came from Prague to Paris. But yeah, there's the speakers. You know, this looks a bit like the things that are now sitting in our class. So let's try to understand this. How do we understand this? So there's an annotation called metadata. Let's look at this. Because everything is open source, right? So let's look at metadata KT. And this is very well documented. So there was a thing called K. I think K was 1. 1 means this is a class. Bam, this was correct. So first thing we know. MV, some metadata version, the version of the bytecode interface. It was 190. This is just maybe coincident that I'm using this Kotlin version here. Just saying. I think there was another one. Let me just switch back. XY. Let's search for XY to understand what XY is. It's the last one here. Bits of this number represents the following flags. 1. This class, no, 2 here 2, right? This class file is a compiled Kotlin script source file. Yes, because originally I used the decompile button in IntelliJ, which just runs a KTS script that just creates this. If we run this at one time, there will be, and I will show you, will be a different version. Very interesting. But we're interested in these weird data arrays, right? So what are these, D1 and D2? So we find them here somewhere. Oh, let me just search here. D1. Cool. D1, metadata in a custom format. The format might be different, or even not there. Great, you're not a big help here. Let's look at D2. In addition to data1, an array of strings which occurs in the metadata in plain text, so that they will present in a constant string pool. So for optimization reasons, they're already there, so they will be in a string pool already. It gives us some hints. There is some relations between the two things. But this is not so helpful, so I think let's find out a bit more. So how do we find out more? Let's use reflection to get this annotation from our own class. So let's use Android makers. Grab the class, grab the annotation. Let's find annotation. And I want the annotation called Metadata class. Find annotation, wait. I think it was find annotation. Too many arguments are public and then, okay, either or. Okay, cool, then. We can do it like this. Let's print this and see what it does. Any guesses what we'll see? Someone using reflection before? Okay, cool. Actually, just let me know because this will not work. We have some Android makers weird thing running around here. So now, this annotation is not there. Wait, but I mean, you didn't saw it, but it is actually there when we look at. So why is this? Because we really didn't make a mistake. We asked in a K class for annotation, but wait, it sits on a Java class. So it's not here. We have to go to this guy and asking get annotation. And then it's metadata class.java, because we need the Java version of this thing. And let's print this. Let's see if we're already better here. Ooh, we're having a metadata. And look, it's now 48 and not 2, because we're actually using a proper compiler here, so there are different bit set flags there. And there's some weird thing here again. Cool, so what do we do with it? So let's grab this metadata and maybe put it in a variable. Well, meta. Let's call it just meta. Cool. Already nice, it's a nice class, right? It shows us some, there's data1, there's data2, there's these extra ints. At least they have some nice naming, so even if we wouldn't have had the documentation we just looked at, this will give us some that K is probably kind for class. But we still want to figure out what is data1 and data2. And don't ask me why, but I'll show you later where. I found something which is in the reflection tool. You can all use it. It's called JVM name resolver. No, wait, JVM. Give me a second. This one I need to cheat. But I have a second computer. Easy. So I can cheat without you seeing the solution. Because I definitely forgot the name of the method I want to call here. Oh no, it was actually correct. It was called JVM protobuf util, which gives us a hint what this weird binary thing is. So this is just the class util. The util is why I didn't find it. And this has something like read class data from. And it takes two arrays. We have two arrays. What if happen if we pass those in? So let's pass in metadata1 and meta2. Meta2. Cool. What does this thing give us? A pair of a name resolver and a protobuf class. So this sounds weird, but let's grab these. And so I think the first time in my life I'm using the structure and declarations. So it's a name resolver and some protobuf content thing. Cool. What does this protobuf class give us now? For example, it has all the functions. It has all the properties. It actually has pretty much everything that you would look for later in the K class. The constructors, the enums, whatever is in this class. So this protobuf thing has it. So let's try to look into some of this. So let's try to find our functions. The functions in this class. So let's do function list.forEach. And then let's get the name of the function. There's an int. The name of the function is an int. That's weird. So maybe it's related to the string array that we're having, right? And there's a second parameter called name resolver. Maybe it can do something with ints. So let's do let's take the second argument called the name resolver. And there's no method called pretty, it's just a little alias I show you. This is just a shortcut to what we're trying to do. It.name, and the second one wants the return type, it.return type. Cool. Let's run this and maybe add a print line around it. Print line. Come on. Running. So it found the hasStarted method that returns a boolean and the start event method that returns unit. So all the functions, all the properties we could now iterate on. And just to show you that pretty didn't do much, it just added the fun in front of you so that it looks nicer for you. So these cool utils you'll find, there's some interesting stuff when you start looking at the reflection package. For example, in one project I have an older version where the type of wasn't available either, and I needed to create an enum. I'll show you. And in enum dynamically creating, although there is a Java API, the compiler does really not allow to do this in Kotlin. To give them, hey, I tell you the class, I tell you the value as a string. The compiler doesn't allow you, so the trick that they do, they created a Java class in their package, doing the exact same thing. And referring an issue in Kotlin to allow this was actually should be possible. So these kind of utilities is fine. So how did I find this? Remember very early on there was this is_odd function that I had. Fun equals is_odd. Wait, does this doesn't work? We already had this for fun, so we can reuse the old one. So we had this fun one, and I said there's this reflect method, right? So let's now I show you what this reflect method that took a lambda and makes a k function out of it did. So it grabs the metadata annotation, then it takes the name resolver and the protobuf with this JVM protobuf util, so we have an idea where I found it. And then just creates new metadata, there's some description, and in the end it creates a k function impl, which just implements k function with all these scripted data and reads them out. So this is how the whole thing works under the hood. So everything sits in annotations, and there's like all the utilities are available for everyone. There's nothing you extra import except for reflection in your project if you want to do some of these things. Cool, let me just check how we are on time. That's pretty good. Let's go back to our code. Cool, I'm not calling reflect here. This was the metadata one. This was just the values in case it didn't work. So some examples of things that you can do with Kotlin Reflection. So one is a delegate that a friend of mine using. So we're actually using a lot of delegates. We worked together in one company before I worked at SoundCloud. And even at SoundCloud, we're using some of those. For example, SoundCloud is Rx Java heavy. It's a monster. Rx Java will always be there. It's one of the heaviest Rx Java code bases. We have to handle with disposables like everywhere. And one we have is called bytedisposable. What it does, it's a field, it's bytedisposable. When you assign a new disposable, it disposes the previous one. So just by assigning, it just gets rid of the previous one. So these things you can do with delegates very, very easily. Or we have a similar one for like temp files. If you assign a temp file to this field, make sure you remove the other one that was there before. Because obviously it looks like we're not doing it anymore. Here's one that my friend Aiden wrote. So we might have all have view models if you're Android developers, which hopefully Android makers you are. And you probably have something like this, where you have a string, and this is a mutable state of, just a normal bi-immutable state of. You're actually using a delegator. But then you also now have a saved state handle since a while. And so make sure that when you come back, the values get restored. So you have kind of two things you have to mingle. So he wrote this savable mutable state of, that you just pass in the save state, and does everything under the hood. And we can look at the implementation. And this is a bit like what I showed you earlier. So you just have the method that you turn to delegate. It looks a bit nicer than what I did with Android makers. So there's this provide delegate dude that shows you, that gives you the delegate. It's a read-write property, this marker thing that I told you. It uses something with the this reference because it doesn't do much, but it's a lot of like how you creates the keys and values. So in the end, it just dynamically creates some keys and values to save these things based on their name. You might say, oh, this is slow reflection. We'll talk about this in a second. Cool. This is something we can do. For example, a very nice use of delegation. And there wasn't much code, even if you don't understand it right now, the short moment I showed you, but this was all the code that is behind the save state handles. Code. Cool, nice. Limitation. Oh, let me show you another example. So the whole idea where I started, I think like 2018, 19, was I had, no, it must be 19 because I was already at SoundCloud. So this was something that we have in our code base. So let me go, wait, command 1. There's a test folder here somewhere. Because you know me, I like to write tests. And then, so we have a test here. Let's assume this was the case that is easily supported in JUnit 5. I have a login method. It's Facebook, Google, or Apple. And then I have a method where I need to test all these cases. So there's a parameter as test in JUnit 5. And then you say, this is an enum source. So please provide me all the values of this enum. And it calls us 3 times. So when we run this, let me open this here. Huh? Ah, the other one? Yeah, no. Thank you. Told you to not make a computer. Yeah, just want to make. So it just calls this method 3 times with this value. So as would there be three methods. But my problem is what we had was something like this. So there's login method, which is a sealed class. And there's social logins, which are just objects, Facebook, login, Apple. But there's also a manual one that gets an email or maybe a password, whatever, right? And I still wanted to have this kind of functionality. So I wrote a parameters test and a class that is open source back then, sealed class source. That does the same thing, so I'll show you. It calls us 4 times with basically every variation of the sealed class. So why do I need the deflection there? Because I needed to instantiate this thing called manually with a parameter. I have no idea what it is. So let's see if I can jump into the code here. Let's see, maybe the decompiling will help us. Oh, by the way, here's the metadata annotation. This is what we wanted to say earlier, by the way. Let's see if I see something. I don't have the original code on the other project. I would have had it. Very unfortunate. I can show it later. You'll find it online. So basically what I have to do is take the class, take the k type, and check like, okay, if this is an int, the value is 0. If it's, I don't know, a string, it's an empty string. And then recursively walk through all the parameters and do all these things. And with the sealed classes, it's easy. The k class, give me all, if it's a sealed class, give me all the subclasses. So you can walk through the whole hierarchy and instantiate all these things. And this is how the sealed class data source works. It looks a bit weird when you look at it, a bit complicated, but actually not that much of code to do. For the enum one, I stumbled upon this case that I told you it is not impossible. It wasn't possible in Kotlin in earlier version to instantiate an enum dynamically, although the Java API is there. So I did the same trick. I copied the Java file in. Cool. This was another example where you might handle with reflection. Let's go back to the slides. Give me a second. Slides. And we can collapse this. Come on. We can do it like this. I forgot the shortcut. Cool. Limitations. So the whole, I remember when I wanted to give this talk, and I told someone, a friend of mine, I think at Google, about it. Hey, I'm giving this talk about reflection. She said, what do you want to talk about? It's like 3 classes. In the beginning, it feels like that's reflection. There's not much there. Because the whole idea is it's very limited. It's about to introspect your data at one time. It's to add all the things that Java cannot give you, because it doesn't know, or didn't used to know about sealed classes and all these things. It doesn't know about data classes, coroutines. So it gives you these APIs. But a lot of things that you use with Java reflection, Kotlin doesn't have an API for, like getting a private field from reflection. You have to use Java one. Or I have an example, for example, one. Let's see if it's imported here. So on, yeah, on, let's say, Android makers. Class, or an instance, I think I need, right? Yeah. Dot set, I want the reflect one. Set the world costs, because it's not public, to, I don't know, I think it's a big decimal, not one. So this is a very cheap conference now. You can also make it a bit nicer. Wait. Wait. What is actually there? Okay, you just want to, the input, there's the input one, replace 2 with index. Looks a bit nicer. So this uses just Java reflection under the hood, because such kind of things are not possible. This is also a small example where Kotlin Reflection, they don't have an API for this. You have to use like a library like I'm doing here if you need this. Very happily, I haven't needed it in a long time, but I've worked at code bases where, especially for testing, we had to do these ugly things and set something just to make sure that we can unit test this, because the unit tests were written in a bad way, or the code itself. So let's talk about the elephant in the room. This is reflection, and I'm doing this because we're getting close to class, to the questions. And the first one is always, but reflection is slow. And yes, reflection is slower than not using reflection. But also running code is slower than not running code. I remember, so this question came up a long time, and it came from a very early version of Android, where the Android team said reflection is really much slower than you expect compared to the Java world. This is a long time ago, and I think there was some Google I/O where I think Chet said, yeah, it's okay to use enums. We don't use them internally, but you can use them. It's also okay to use reflection. Actually, a lot of change happens, talking about like the way the compiler works. Reflection is not as bad. But even a few years ago, so I remember at 2018, I think, I was in St. Petersburg with a guy from Groupon. They had just launched a dependency injection framework called Toothpick, which was like a little dagger. And they were using partially reflection, so it wasn't completely code-generated, but not as bad as the original reflecting-based injections by then. But we knew that the question would come up. So we ran like a lot of tests. So how slow is reflection? And it was like surprisingly, and the data, you can find the presentation online, and I can also dig it out. It wasn't as bad as you might think it is. There were some surprises there, but for small things like your delegation, like use common sense, right? You don't want to write your whole app in reflection, and probably don't want to millions of items with some reflective things, right? But for some things like this K-property stuff is already reflection. But if it makes my view model much easier to read because I have a delegate that does it, give it a chance. And in your test, you can do whatever you want anyway. Cool, to sum it up, you have a performance overhead, you have very limited access to private members. It is definitely less type safe. Remember this morning, the call method is just a var arg. If someone changes something, it doesn't see also the default arguments, things like this. So you lose a lot of the values that Kotlin gives you. This is why they just gave you the minimum. It is still a very powerful tool. You can come up with new use cases, like thinking about a class, something is used, and then, I don't know, I know your colleague. There are some links that you can read about more reflection. Also the two tools I was using, the JUnit 5 one, and this reflection tool, just in case you need to set a private variable. This is just the Kotlin API for this one. Let's just use another library under the hood, so there's not much code there. Then we have, I think, a few minutes for questions, and I say thank you. I just put the links back on in case you need them. And the laptop did not break.